A recent study highlights a concerning trend. The Atlantic Ocean currents are slowing down, and these currents are crucial players in shaping global weather patterns. How do we even have currents in the ocean? It's mostly about temperature and salinity. These factors change water density, which drives currents. The Gulf Stream transports warm waters up from the Gulf of Mexico up the East Coast, cooling and releasing heat into the atmosphere as it goes. Evaporation starts to take place and increases the water salt concentration, making it denser and heavier and causes it to sink deeper into the ocean. The cold, dense water then flows south below the surface. Eventually, it resurfaces and warms up and completes the entire circulation cycle. But something is causing a disruption in the cycle. Melting sea ice in the Arctic is messing with the way the ocean currents behave. The melting sea ice adds fresh water to the ocean surface, reduces the amount of salt in the water becomes less dense, and it's harder to sink. When the surface waters can't sink to those deeper levels, the entire current begins to slow down and stall. When the Gulf Stream slows down, it can't transport that warmer water up to the north effectively. The warmer water starts to pile up along the east coast of the United States. The actual height of the Gulf Stream increases as the current slows down. And guess what that means? Our coast could face a larger storm surge risk as tropical systems have more fuel to work with. That flow has already been reduced by 15% in the last 50 years. Several studies have shown it hasn't been this weak in over 1,000 years. But what would happen if the Atlantic Ocean currents totally shut down? That could lead to our next ice age? This study didn't take it that far, but the researchers did use model simulations to see what this might mean. The simulations painted a chilling picture of a world transformed by the absence of the Gulf Stream and its crucial role in regulating global climate. The entire northern hemisphere would turn much colder. The southern hemisphere would warm dramatically as the transport of warmer waters to the north would no longer happen. We would have dramatic climate changes across the entire globe. Winters would be more harsh in the United States, precipitation patterns would shift, and most of the northern hemisphere would get less precipitation. Ocean currents maintain a delicate balance in global weather and climate. Disruption could render many places uninhabitable and threaten species survival. To prevent this, we must mitigate climate change by preserving Arctic ice. Shared global determination is crucial to navigating the challenges ahead.